Good morning, everybody. Unfortunately, we seem to have lost our chair, Neil Witten, who is the Advanced Materials lead for Innovate UK. My name's Steve Morris. I run the Metamaterials Innovation Network, and this is the second workshop we're running. Webinar that event we're running, and it's on scale up and commercializing metamaterials. And we've got a series of presentations that will enlighten you as to the support that is available for SMEs and small companies. I'm not sure how confident I am in presenting Innovate UK, but I'll give it a go. We're basically running to the schedule you can see on the screen here. So Neil supposedly will be talking about support for SMEs and spin-outs. And then we're going to have a look at the innovation canvas with John Bound, some access to markets and pitch training from UK Edge and Stephen O'Leary. We're looking at scale up and de-risking with a representative of the high value manufacturing catapult, Alf Smith from CPI. They're going to have a look at some of the academic support that we can access, looking at modelling with Tim Starkey from Exeter and additive manufacturing with Lyudmila Turyanska from Nottingham. And then we have our designer in residence, Duncan Fitzsimons, who's going to talk to us about engaging with designers at the early stage. Then have a colleague, Emma, who's going to talk about accessing finance and what investors are looking for. And then we're going to finish off with a question and answer session just before a break at 12 o'clock. You'll then have the opportunity, if you haven't done so already, to book some one-to-one meetings on the Meeting Mojo, and all the speakers will be available. We have somebody from intellectual property, is Jason Tang from Potter & Clarkson. He will be available, and also Melissa Riley from TWI. They're involved in scale-up support as well. And now Neil's back. I'll leave him to run through the slides. Well done,
So
Neil.
my apologies for that, everybody.
That's okay.
A bit of a breakdown on the old technology. So apologies, everybody, again. My name's Neil Witten. I'm Innovation Lead for Advanced Materials at Innovate UK within the Manufacturing Materials sector team. For those who don't know what Innovate UK is or who Innovate UK is, we're the UK's innovation agency. Effectively, we try and connect business to the right people to help businesses grow, excuse me, and to reap the social benefits from the innovation. If you move on. So we're part of UKRI, which is an organisation that was put together about 2 years ago. Excuse me. And brings together basically the research councils and Innovate UK and Research England. We are central to delivering the government's industrial strategy and net zero strategy, and also in delivering the target of UK R&D spend to 2.4% of GDP. So we're an agent of change, trying to drive innovation to increase productivity and help business grow. So we support innovation from spin-outs and startups, anybody really with the ambition to scale and grow their business in the UK, but also globally. We do put in quite a bit of effort to international work. And we help companies of pretty much all sizes. In pretty much every sector. And a lot of our work is connecting those people with the right partners, the right investors, and introducing them to the right markets. Yeah, if you move on, please. So where is our funding deployed? So the typical area is in that kind of TRL 3 to 6 range. The research councils very much working with academia in the early stage, TRL 1 to 3, and then Innovate UK, our core grant funding work is in that 3 to 6 area, 4 to 6 area again. Beyond that, Innovate UK also has, what we term the ecosystem, the catapults, the KTN, for instance, and others who work right the way through with businesses right at the commercial end. But those who are familiar with that kind of pink shaded area in the middle there, it's often referred to as the valley of death for small business. That's really what Innovate UK is about. It's about supporting businesses through that most difficult stage of growth, where technology is proven and may have an application, but really needs to be supported through that process into the commercial world. Next slide, please. So we do provide quite a broad package of support. Again, if you look far left, the grant funding and finance column, we provide funding and grants to single company projects, to multiple company projects and collaborative projects, whether they be business to business or business with research and technology organizations. We also provide innovation loans, for instance, at slightly preferential to market rates. The other thing that's not listed on there, SBRI, which is the Small Business Research Initiative, really puts small businesses in touch with public sector bodies which have challenges. So, it may be a challenge from the Ministry of Defence or from the NHS, where they have a problem to solve, and we put them in touch with innovative small businesses who can provide the solution to that, and ultimately, hopefully, providing them with procurement contracts. Innovate also manages programs for instance, BEARS, the Department of Business, Energy and Industrial Strategy. So the managed programs, for instance, the Aerospace Technology Institute and the Automotive Transformation Fund are managed through Innovate UK. And that's really because we have systems in place and we have the experience of managing the kind of competitions for funding. And then finally, I should mention the ISCF, which is the Industrial Strategy Challenge Fund. These are challenge-led competitions, really, but quite broad. They come from the industrial strategy that the government published a few years ago, which was around 4 key themes. But actually, the ISCF challenges, there's around about 20 of them, I think, running currently. So ones you may be familiar with, for instance, the Faraday Battery Challenge, the Transforming Foundation Industries Challenge, Smart Sustainable Plastic Packaging. These are all examples of the ISCF challenge-led competitions. And then we also have links into private sector finance we have run in past investor partnerships where early stage investment bodies and Innovate UK will jointly operate competitions. So providing funding for them to grow, but also having kind of equity partnerships for them to continue on once the project is complete. And then pitch fest programs, which I'll mention, but I suspect one of the other speakers is going to talk about also, which is really just getting small businesses ready and in a position to make a very good pitch to investors. Under the same remit, really, the growth and innovation services, I'm probably going to just quickly skip over here because I think Stephen O'Leary, my colleague, is going to talk later and probably will talk about this in much more detail. But these are really just advisory services, very important support services to businesses that, once they have project funding, these are services that can look at the business in the whole and where they want to go to, and supplying them with much more support to access their key markets. Our centres and networks, very important. Obviously, the knowledge transfer network, we're operating this workshop. We work very closely with the knowledge transfer network across all of their areas of expertise. We also have the Catapult network, which is a series of 9 major units that are spread across the nation, to be honest, and then there are also clusters around them, and these work in very specific areas, but work at at almost an industrial level. They have full industrial scale equipment and a lot of industrialists working with them, scientists, engineers, to help support business much further, well, further up, but all the way through the TRL level from 4 through to 9. The two that I've highlighted on there, the high value manufacturing catapult and the compound semiconductor catapults, perhaps the two most relevant for today. I'm not saying that the others aren't at all, but two I picked out, and I'll talk about them a little more in a moment. And then in terms of talent development, equality and diversity, we have the knowledge transfer partnerships. Again, I'm going to touch on them in a second. And but a very useful way of bringing in new skills and supporting those skills through a project that has industrial relevance. The Future Leaders Fellowships, Women in Innovation, and Young Innovators exercises are also about us helping equality, diversity in specific areas that are underrepresented in industry. And lastly, on this slide, international activities. So Innovate UK, while UK is in the title, it's very difficult to ignore the rest of the world. So we do take international expert missions. So we'll take groups of companies abroad into specific areas where there's felt to be relevant to understand what the nature of the technology is in other countries. And again, to primarily to form networks and links between those bodies. Typically operate those through the business innovation programs, the incubator programs, but we also run bilateral and multilateral R&D programs. For instance, at the moment, there's a bilateral funded program going on with the US and the UK in the area of composite materials. And we also have other programs to support global business development. So although we're quite well known for the grants and the funding, actually we have quite a wide portfolio, and it's not simply about handing grants out to business. We want to support them through that growth phase as well. Next slide, please, Pam. So where can you find more details? Well, it's all in really one place now. That link at the top of the page, all UKI funding opportunities are on the one website. You can search for funding across the councils, whether it be PSRC or Innovate UK or any of the others. It's worth noting that funding is a competitive application process, and depending on competition, particularly the open competitions, they're usually very heavily subscribed. So it's always worthwhile taking a bit of time to make sure that your bid is the very best it can be. And I know, for instance, the KTN and others will certainly support you through that process. Currently, we have about 8 open competitions across various disciplines. And the one that is a fairly regular competition, the Smart Grants, are open to all. And there is a competition open at the moment. Next slide, please. So just on that particular topic, our smart funding grants are basically enable any business in any technical area or in any industrial area to apply for grant funding. It's that open. So funding is it's a very competitive process. Again, as I said, it's always heavily oversubscribed. And really what we're trying to do is fund the very best proposals through that process. The current competition that's open has around about £25 million of funding available, and that will be closing, I believe, on the 26th of May. So, if you're interested in applying for that, then there's a bit of time before that closing date. Next slide, please. I mentioned in terms of talent, the knowledge transfer partnerships, so KTPs. I've worked in a business in the past that has run one of these, and it was very useful approach. Basically, the business can bring in a graduate who works on a particular project for that company or that organization, and the graduate is supported by an academic throughout. So the business gets a dedicated person focusing on a particular problem, but also benefits from the fact that they have academic or a research organization behind that. So adding to the kind of the science and the intellectual base. The graduate is typically employed for between a year and 3 years, and the vast majority of their time is spent in the company. So they are, the aim is that at the end of the partnership, that basically that person is employed and continues on as a valued member. Next slide, please. I mentioned the catapults in terms of the kind of ecosystem. So the high value manufacturing catapult has 7 centres across the UK, that spread pretty widely across the UK. And their main aim is to bring the very latest research and the very best of that to market. So working with companies of all sizes, the large and the small, allowing them access to industrial scale facilities and state-of-the-art facilities, but backed up by people who also come from industry typically. So a lot of engineers, scientists and technicians that have huge experience. And the other thing they do is they cover a very wide range. They cover the entire scope of manufacturing. So from raw materials right through to product development, optimization, and digitization and automation. So, next slide, please. The compound semiconductor applications catapult I mentioned here because they do a lot of work in photonics and sensors and RF microwave and in power electronics, and in a very similar mode to the manufacturing catapult. They're supporting businesses with the very latest. Based in South Wales. They may be of use to the metamaterials community, so I mentioned here specifically for that reason. Next slide, please. That's it. I've managed to get back online and I managed to get through it, so I'm quite pleased with that. So any questions, please post the questions in the Q&A box, and we'll be trying to pick those up at the end of the session, as I hope I mentioned while I was cut off earlier on. With that, it's now time to hand over to the next speaker, who is John Bound from KTN, who's going to talk about the innovation canvas. So over to you, John.
Thanks very much indeed, Neil. I'll just bring up my slides in a sec. So I'm John Bound. I'm in the design and innovation effectiveness team at the KTN, where we are part of our role is to develop useful tools both for our own colleagues, but also for innovators in all sectors. Quick bit of background: I've got a background in manufacturing, but I also spent 25 years working at the Royal College of Art, postgraduate art and design, and in various innovation roles. And that's where I met up with Robert some 16 years ago. And since then, I've been very much involved with the Materials and Design Exchange, which is a program to connect and encourage collaboration between the world of material science and the world of design of all kinds, from architecture to industrial design. And so I'm part of the group kind of working on this metamaterials project. And I'm very pleased to see that we have a designer in residence, Duncan, on the program. So today I've just got a few minutes to give you a very quick introduction to a tool that we've been working on for the last 2 or 3 years, which is to help businesses of all kinds, large and small, to succeed and be better at product, service or process commercialization. It's available in various forms. It started off as a paper pack with question cards and so forth, and fortunately we'd started developing a digital version, not long before the lockdowns, which I'll come on to in a minute. Basically, it's a tool which facilitates either one-to-one, team, or indeed intercompany conversations to evaluate an existing innovation project. Could be a completely new, developing a new product or iterations of an existing product. And it's really designed to provide a framework to help you identify the biggest challenges and prioritize actions to overcome them and reduce risk. In its first format, it's we call it a quick and dirty tool. So it's something that you can use in a very short amount of time to give you a very good snapshot of all the things that you need to think about when developing a product or a service. And this has come from a lot of internal and external research as to the kinds of questions that typically come up in innovation processes. As you can see on the sheet there, it's everything from risk to IP, leadership to R&D. But behind this is a lot of supporting materials, which again, I'll come on to. And altogether, we've now used it with over 11,000 entrepreneurs, managers and so forth have used the tool. So it's reasonably well proven across all sectors, everything from cybersecurity to agri-food and indeed materials. Now at this point, because there's not much time, I'm going to show you hopefully a short video, 3.5 minute video, which will give you a quick overview of the tool. And in advance, can I apologize that this is in our old branding? We haven't got round to updating the brand yet. So Poonam, would you mind running the video?
Innovation is almost always an exploratory task. It's often untidy, full of missteps, blind alleys, and changes in direction. It would be nice if innovation was as straightforward as taking an idea from the cloud of infinite potential and turning it into a thingy for the marketplace. But in reality, innovators often start with a great idea, and with a little research, they begin to build. But as they get closer to realizing a final product, they unearth more and more questions about what they're trying to do. Ideally, businesses and innovators would find ways of driving that questioning to a much earlier phase of the project, when they're still working on paper or with prototypes, and before committing significant resource to making stuff. The KTN, where between us we have several hundred years of experience of innovation in business, has created the Innovation Canvas for that purpose. The canvas is designed to help us and the businesses we work with gauge the strengths and weaknesses of a specific innovation project in development, to identify immediate challenges and make clear decisions about what needs to be done as a priority to make progress. Our model of innovation consists of 3 key drivers: the innovator's ability to develop and deliver the innovation, their capability; the perception of an opportunity, something that can be done or made that will meet a need or create value; the opportunity; and an approach to meeting that need that delivers specific benefits to the user, the offer. It's a key principle of the thinking behind the canvas that the innovation journey can start with any one of these drivers. There's no consistent starting point or step-by-step methodology. Innovation is not a linear process. We've adopted the metaphor of a canvas because it suggests an iterative, creative process that may involve initial sketches, false starts, rubbing out, reworking, constant attention to detail, and so on. We've created 2 versions of the Innovation Canvas. There's a paper version for use by an individual with a colleague or in a workshop, and an online version, which lends itself to refining an individual's perspective on the challenges that they face. From our experience, The Innovation Canvas works extremely well as a stimulus for discussion with colleagues and in a workshop situation to answer the important questions early in the innovation process and to identify key challenges that have to be overcome. By scoring each component of the drivers, you can build up a picture of a project's weaknesses and strengths in a relatively short space of time. We want you to find out where it hurts and where you need to pay attention. By helping to clarify risks and remove uncertainty, the Canvas is a powerful tool to strengthen an innovation project quickly.
Okay, thanks everybody. So that video and other materials are available on YouTube and a website which I'll share the link to at the end of in a few minutes. So just to recap there, the model that we adopted is around three areas really. And these can be started at any point you like. So it's the opportunity out there in the marketplace, the offer that you've developed to meet it, and the capability within the organization to deliver. And I think with something like metamaterials, clearly, particularly the opportunity and the offer are something that this metamaterials network is going to be addressing over the next few months. As shown in the video, the paper version down here allows you to very quickly get an overview of the areas to work on. And we've tested this, as I said earlier, with about 11,000 people. So we're fairly confident that the questions we're asking and the areas are altogether cover the whole spectrum of the kind of things that come up typically in innovations. As to the materials and tools that are available, we've got the paper pack. At the end, if anybody would like to have a paper pack, I'm afraid it's in the old branding while we use up the stocks before we go back to live events. If you could drop us a line, either to Poonam or myself, then I'd be happy to send a pack to you. We've got video materials, as I said there, that explain how it's used. And I'll come on to the digital version in the last slide. Neil mentioned earlier the KTP, the Knowledge Transfer Partnership Programme. And at the moment, I believe there are 800 of these running across the country in all kinds of sectors. So these are recent graduates who are placed in companies and act as a bridge back to the knowledge within a university. And they're usually there for about 2 years, and in many cases go on to be employed within the company. And we've been working now with over 80 of these in the last few months. And we've developed a 25-hour course which goes much deeper into the areas that the Canvas covers in order to help them with developing skills as innovation leaders, developing innovation strategies and so forth. And in time, we're hoping to roll this out in various forms, kind of as an innovation 101, if you like, for external partners and collaborators. So that's kind of coming up. So just to conclude, as I said just now, if anybody would like a copy of the printed Canvas, they can either contact me and I'll be happy to send a pack out. You can also download it from the website, which I'll show in a minute. And let me just pop to the website. So this is the online version. As I said, you can actually go to this screen and download the paper version for printing at home, or indeed you can complete your own version here. So as you see, this one is done on a Likert scale, so that there's a series of questions to which you can score yourself from strongly agree to strongly disagree. And at the end of this process, a report is generated, and the report also draws on a library of resources which we've built up to support all the areas of the Canvas. So this takes you to various, either to, for instance, to the BSI, or it takes you to certain tools, so empathy mapping tool, tools on design thinking, brainstorming, and so forth. So that can be very helpful Let me just go back to the slide. So that's my contact detail there, john.bound@ktn-uk.org, or please contact Steve or anybody else in the programme to put them in touch. And you can visit the canvas at the innovationcanvas.ktn-uk.org. I think that's my 10 or 15 minutes up. Thanks very much.
Okay, thank you very much, John. Thanks for that. Looks a really useful tool. So if anybody wants to get in touch with John on that, or any of the KTN guys, I'm sure they'd be happy to help you. Right, the next speaker is a colleague of mine, Stephen O'Leary from Innovate UK, who's going to talk to you about access to markets and pitch training. So over to you, Stephen.
Okay, well, welcome everybody. My name's Steve O'Leary. I'm a innovation and growth specialist with Innovate UK Edge. Firstly, a quick thank you, just to say thank you to KTN for the opportunity to speak with everyone this morning. Obviously, having excuse me. Yeah, sorry. Taking a bit of a look into the subject of metamaterials, obviously fantastic opportunity, both from a technical standpoint and some of the research and development that's going on here, and uncovering some vast range of commercial opportunities for these types of materials. And that's really what I want to talk to you about this morning, is really give you a little bit of background to the type of support service that we're offering through the Innovate UK Edge, really to ensure that these sort of innovations are pushed through to commercialization and scaling. Really a quick agenda for the presentation. I want to give you a little bit of background to Innovate UK Edge and what we can do for you through the types of support that we're providing. I'd like to give you a bit of a case study to one company that we have supported through the scheme fairly recently, and some background to the type of clients that we typically work with. So as the name suggests, it's Innovate UK Edge. So it's logical as part of the Innovate UK family that we tend to work very, very closely with Innovate UK awardees. But that's by all means not exclusive. We work with quite a broad range of SMEs who are active in the innovation space. And I think a good analogy, the type of support they provided, was really to think of support as a wraparound service. So we help companies sort of formalize and execute some of their commercial strategies, sort of post-completion of project awards or the research and development activities. So the type of support we provide is very much customer-centric. So it's very much focused and bespoke to the individual businesses. And that can take the form of either short-term or long-term support. For example, we're working with a number of companies at the moment, working through the impact of COVID-19 on the business. But we could equally be supporting companies through rapid scaling and working towards internationalization. It's all about working towards identifying sort of resource gaps within organizations and help building support packages really to sort of address these needs. And we typically find a lot of these support is around finance or knowledge or skill gaps within organizations. I think sort of returning to the point that Neil raised earlier on, it's all about Innovate UK providing that support and nurturing growth. The packages that we do, that we are offering are typically fully funded by the UK government. So it's really a case of UK PLC making an investment in you and your business. The government's invested in you for future contribution to the UK economy. So really, it's really about a mutually beneficial arrangement. So what form does this support take? Well, it really depends on the organisation is within their growth journey and the specific needs that they have. As I said, it's really about being bespoke. So, for example, we could be engaging with fairly early stage businesses, and that could really be focusing on innovation management, such as advising on intellectual property rights, etc., or helping those companies prepare for market entry, and that may be helping them develop marketing or manufacturing strategy. Now, as the businesses develop and start to mature, their focus may shift more towards internationalization and scaling, and we can support in those sort of areas as well. So, in terms of the support team, we have a range of advisors that are based throughout the UK, and they have quite a diverse range of backgrounds. For example, the cohort that I work within the Wales region, we have a number of entrepreneurs within the organisation, and we have specialists within finance, marketing, and manufacturing, etc. I think we can all agree that the UK is a fantastic source of innovation, but what we really need to ensure is that this innovation really is converted into tangible long-term businesses. So we tend to work with companies, as I said, throughout their growth and development. If we're working with early stage businesses, we may be there to ensure that they advise on introduction of suitable financial controls within the company, help them develop their financial strategy so that they can actually achieve their innovation goals. That could be working with grant or funding, equity funding opportunities, or identifying R&D tax credit. Now, as the companies grow, their priorities will change, and that may mean starting to work with them in terms of developing for second round funding, or working on working capital strategies as the demand on their cash, or working with larger collaborative grant funding schemes. I think it's worth mentioning the Scale-Up program that we run at this point in time, and that's a real sort of high-intensity offering where we'll appoint a dedicated Scale-Up director to work with the companies and really preparing them for that high-intensity growth. At this point in time, we're accepting around 20 companies on that particular scheme. It's also worth mentioning that as part of EN, we're part of the world's largest support network for SME businesses. As the EN, we operate within 65 countries and have over 600 member organisations in that particular network. We're all there really to encourage international partnering opportunities, and that may mean locating overseas manufacturers or distributors for goods, so accessing overseas markets, or it may be working collaboratively on technology or expertise exchange, really to drive innovation forward. Some quick notes on some of the support that we have provided. Innovate UK Edge, we've provided support to 585 clients who have signed long-term collaboration agreements with overseas companies. 54% of those organisations have been able to create more jobs within the UK, and 88% of those companies reported that the support that we have provided has helped reduce barriers to growth through innovation. So I'd like to give you a quick background, a quick case study on a company that we have supported in Wales fairly recently, an organisation called Lyudmila Limited. Now, this particular organisation is involved in the design and manufacture of condition monitoring systems for deep drilling operations. The company's got some extremely innovative and exciting technology in the thermoelectric space. They've developed systems that can harvest and store energy at point of use. And there's some tremendous opportunities for this within the deep drilling operations. Now, the company was impacted quite severely, as you can imagine, from COVID-19, and that really was impacting on the ability of the business really to transfer a lot of the research and development into demonstrators. So we've engaged with that company through the business growth support offering. That particular scheme will give companies around 5 days of fully funded advisory services. And as you can imagine, on this particular application, what really was around focusing on the finance requirements. So our team of advisors work with the company really to identify potential sources of funding for them. And then once a particular source that looked suitable had been identified, we worked with the company in terms of providing guidance on the preparation of our application. And that's resulted in a successful application through the Innovate UK continuity loan, and that company has now received in the region of £500,000. That's really allowing them to push forward in that particular development. Without the support of the loan, that would. In terms of the type of clients that we tend to work with, tend to work with businesses with SMEs with turnovers in the region of 2 million plus or 10 full-time employees. But for us, the key really is to work with companies that really are exhibiting or really have the potential to grow and scale those businesses. And we realise that the barriers to support of £2 million may be quite onerous for a number of sort of earlier stage businesses. So all companies really are assessed on an individual basis, and really the emphasis is on what innovation is present within the companies and that potential of that business to scale. So no companies are off the radar. Which sort of brings me on to the one offering that we have at the moment, and that's our Pitch Fest. Now, Neil mentioned this very, very briefly early on. This is a service offering that we run in this particular year, and it's offering a 15 companies really to go through quite an intensive training program. And that training program is essentially designed to teach the participants how to teach investors. We're talking about companies that are looking to scale and look for investment. So the scheme will involve around 2 days of quite intense pitch training. Participants will have access to a number of leading investment experts, and that means real life investors that have invested in organizations and companies. And the purpose of having those individuals on the scheme is the fact that they can actually give some real constructive and no risk feedback back to the potential investors. So it's all about preparing the companies, debugging the pitch, so at the point when they are ready to take their product offering or the business offering to market, they're in a really, really strong position to do the investment that they're looking for. And obviously, there's going to be actually discuss and network with some potential investors in the Pitch Fest. So I appreciate that. That's a very, very broad brush introduction to what we're doing with Innovate UK Edge. I would say that there's a really good website that been launched. I would urge you to take a look at that. I'm going to be around for the Q&A and the one-to-one sessions later on this afternoon. So if you do have any questions or you would like to talk through some of the support that we can offer a little bit more detail, obviously I'd be more than happy to help you and spend some time. Thank you very much.
Thank you, Stephen. Thanks for that. And, as I mentioned in the first slides, Innovate UK provides quite a range of services, and it's a very important one. I think Stephen's just reviewed there. So the next speaker, I'm slightly guilty of, Alf Smith from the Centre of Process Innovation is going to talk about support for scale up and de-risking. I should have mentioned that the CPI that Alf works with is one of the founding members of the High Value Manufacturing Catapult. So I apologise for not mentioning you up front, Alf, but carry on.
No problem, Neil. Apparently I'm squeezed for time, but I've got 29 slides, so bear with me if I flick through a few quite quickly. Hang on, already in trouble. Oh, it's working now, fine. Yeah, so just to get going and show the wide range of stuff for the catapults, is all these industries are worked in the high value manufacturing catapult. We do everything from biologics, pharmacy, right through to electronics, digital, and the work. So it's just give you a large spread of industries, and we have big networks to match these we work with in industry. We talk between each other and do sharing activities, and the one area I'm interested in electronics a lot. We have an electronics forum in the high value manufacturing catapult to go across the scheme. To give you an idea of size, we have 7 centres in the high value manufacturing catapult. We have lots of projects with SMEs, and we're a business essentially with core investment from Innovate UK. We have commercial activities, and we do collaborative projects both in the UK, in Innovate UK projects, as well as EU and Horizon 2020 and the new Horizon bids. As we said, we're quite spread out across the country, but the high value manufacturing catapult's got 7 centres. Those centres are widespread across the UK. CPI itself is in the northeast, operating in several centres itself, and there's the advanced formulation catapult, national composites in materials for aerospace. CPI cross-sector. We're the only centre that's not involved directly with the university. We work with all universities. Advanced Manufacturing Research Centre, big business in advanced manufacturing. We have contacts in the Manufacturing Technology Centre near Coventry, and with the Warwick Manufacturing Group. With Coventry Group in manufacturing, we have Electronics Group, Warwick. We work in battery technologies and all sorts. So the idea is that we get money from the government. It comes into the catapults. We work in our area of the 7 high-value manufacturing catapults, and we work with industry, both small SMEs, large, and academic. And what we try to do is what Neil said at the beginning, is we try to help companies develop, get technologies out, scale up, commercialise to get towards products. We go from TRL level 3-ish, maybe 4, as far as pilot scale production to prove concepts. And we get some commercial market activity to show where it can go. So we try to be industrial relevant. We have expertise and partners, and we try and just generate to go towards a business. We're not researchers, we're developers. So we try and fill that valley of death to get it through the difficult scale-up process. So we do proof of concept, reduce risk, and hopefully decrease the time to the market, which is an important aspect these days with so much technology going on. And we support academia wherever we can in support in spin-outs and activities with placements, try to get bids together. We have a whole range of bid writers, expert biz writers to help get these projects underway and find opportunities for both the partner and ourselves and link to other collaborators. We do work for service for a fee commercially. We work globally in that area, and in collaborative projects. As example, we've just won quite a large European bid on battery management systems, where we're dealing with a UK SME on sensors. We're integrating it and linking it to the battery management system. So we work and collaborate wherever we can to get projects and commercial opportunities. And we support collaboration with grants, as I mentioned. And we have an innovation integrator system where we help SMEs and smaller companies through the tortuous path of going towards commercialization. So one of the areas of main interest, which could be interested in metamaterials, we are not experts in metamaterials. We could be using some for all we know, but we don't categorize it as that. We categorize it as an area of application and where we want to go to meet a commercial need. There's a clean room at CPI where it just shows our facilities. That's a class 100 clean room with extensive large kit. And why we're interested in metamaterials? Well, we're interested in the application areas. Internet of Things, antennas for communications, connectivity, basically, all sensors, smart integrated materials, smart labels, smart packaging, energy scavenging. We want to drive our devices as independently as we can, and smartness integrated through electronics. So we're across the areas, and we have commercial or industrial trained process engineers from the semiconductor industry and display industry. So we have the experts at our tips who can drive our tool sets in a well-functioned way, and we have superb support facilities so they never break down, or very rarely. So we go to volume and scale, printed antenna as an example. We have pick and place for large area electronics and embedded intelligence. But we're looking for the opportunities, and we'll see what tool sets we can apply to your metamaterials work. And we do novel electronics of all sorts. So metamaterials could have a big role there. And we do flexible, a lot of roll-to-roll, pick and place, smart packaging. We try and make things smart in an electronic way. It'd be nice if they were independently powered from energy scavenging devices. And of course, that may be a possibility with metamaterials, as it is for sensors, optronic devices, etc. We're not the experts, people out there are, but we'll try and help you develop. We have roll-to-roll capabilities. We have a large pick and place assembly, one shown in the middle with flip chip to put chips on in array at meters a minute, production speeds, printing technology, and all sorts of processing techniques which we've got in our clean room facilities. And there's just an example of the sort of machines we got, from atomic layer deposition, which could be interesting for conformal coating, very thin nanometer layers, through vacuum deposition, photolith, full photolith room, nano imprint, laser patterning with a femtosecond laser, lots of roll-to-roll printing and small printers to see what could be done. We embed into 3D materials as well with some of these devices and in multiple layers. And of course, we have supporting metrology for this where we need it. And if it's specialist metrology, we go outside to get that done at universities or somewhere else. In formulations, we have a big group, all industrial chemists. A lot of CPI started as an ICI research group, and some of the old timers all still got their ICI pension, and I'm sure they're looking forward to those. And we do everything in the nano materials area, nanoparticles, and making them into a printable ink in many ways. In that formulation area, which is is separate from the electronics, we have a lot of scale up from 1 milligram to 10 kilograms. Experience in nanomaterials in the large scale, success from SMEs to large companies, and optimizing the materials for things like 3D printing techniques and other formulations, electronic as well as others. We deal with the Manufacturing Technology Centre near Coventry, and they have an interesting piece of kit. They're mainly based on PCB electronics, pick and place, and that area, smartness, 3D printing. And one of particular interest is in their MTC electronics area, and that's the Dragonfly 3D printer, which is a continuous operating tool for a layered approach to PCB. And in this, you can do high resolution inkjet printer technology in a 3D fashion with nano inks for the performance in 3D created objects. There's some examples, conical inductors, and this could be useful for building up a 3D metamaterial metastructure. And I'll thank you very much for that break speed presentation.
Thank you very much, Alf. Whiz through that.
I'd just say that we do incubate companies as well. And as an example that you may know is Pragmatic. So we do a lot of interaction with companies, but we are on scale up and commercialization.
Okay, thank you very much. Thanks a lot, Alf. Right, we're going to move swiftly on to the next speakers. I just mentioned if anybody's got any questions, please post them in the Q&A box, and these will get picked up, and we'll be covering them in a short Q&A session at the end. But for now, it's over to Tim Starkey to talk about modelling metamaterials.
Okay, so thank you very much. And yes, my name is Tim Starkey. I work at the University of Exeter as a research fellow on a DSTL-funded project on acoustic metamaterials. And by virtue of being here some length of time, the task of talking about the different modelling we use across the electromagnetic and acoustics domain has fallen to me. So I'm just going to give you an overview of some of the research that we do, some of the industrial partners that we work with, and then give you a few examples of the types of research that we're interested in, with some particular focus on the microwave and acoustics. So for those of you that don't know, at Exeter we have a Centre for Metamaterials Research and Innovation, and within that centre we have an EPSRC funded Centre for Doctoral Training in Metamaterials, XM2. And what this means is that we have a body of over 30 academics, and to date we've had over 100 PhD students that are either studying or have completed their PhD with us, working across a number of areas. So these are the big 5 research areas. We have a big interest in acoustics and microwave metamaterials. We also are interested in fluidics, and there's some crossover between the acoustics and fluidics. We have a large body of work going on that's under this umbrella term quantum, and then everything that happens at frequencies higher than about 70 gigahertz falls into this visible infrared and terahertz category. So there's a big expertise spanning quite a large number of different wave phenomena and different length scales. So just to give you an idea of the types of industrial partners that we work with, this is the current list that support the centre. We also work with others in contract research and consultancy, but I haven't labelled those there. But you'll see we get a bulk of funding from government and companies that you would consider to be traditional defence, security and aviation companies. But we also work with smaller and medium enterprises across that range of science. So there are a number of ways that we actually work with these partners. Some of you will be very familiar with how this happens, but I just want to flag up there are 4 ways that this typically works. One is through a consultancy arrangement. The second is through like short-term contract research, and these are similar. And then the other 2 ways are more, enable more substantive research, and these are collaboration through things like KTPs or through shared grant proposals. A good example of these is the defence and security accelerators, the DASICles, where you require basically an academic and industrial partner to kind of speed up the development and produce a demonstrator or address a particular issue at the sort of low to middle TRL levels. And then the fourth option, which is really nice and enables a huge amount of engagement with industry, is to sponsor student PhDs. So these work in a number of ways. Sometimes they're very, very hands-on, where we have industrial supervisors that meet weekly with students. And then there are other arrangements where we might meet quarterly. And there's a flexibility over the degree of oversight and steering the direction of the research for either fundamental level or low TRL projects. So since we wanted to talk about modeling, I'm going to note we use a couple of different tools within basically the acoustics and microwave group, both analytical and numerical modeling primarily. So most of the work we do is experimental, and we're using these tools to basically test theories, develop new exciting bits of physics, or create devices that we'll then go on to measure. So the analytical tools we might use might be relatively complex, like spectral transformations and micromagnetic theory, or they can be actually very simplistic. So for example, in the acoustics, you can learn an awful lot about system when you consider masses and springs, or you can use LC circuits for electromagnetic problems. And where these analytical models don't necessarily apply, we'll usually appeal to some kind of numerical technique. And we have quite a lot of experience in different FD, TD, and FEM methods. And those are just a list of the kind of packages that we use across the center. So without doing a big advert for ComSol, the bulk of the FEM modeling that we do in the center uses ComSol multiphysics. And for those of you that aren't aware of that, basically you buy the package, and then you can add in different modules depending on the physics that you're interested in looking at. So on the right-hand side, I've just listed the main modules that we use. And we find that it's worked very well over traditional analytic methods, particularly when structures or the physics that you're trying to solve becomes very complex or non-trivial to write down mathematically. And it's also worth noting that we have some commercial licenses already in place, which enable us to do sort of commercial research that we wouldn't ordinarily be able to do with an academic license. So I'm just going to give you a couple of examples now. So this is a typical problem that we've been working on with Cobham and TCS on design of lightweight antennas for applications on fuselages for aircraft. And it becomes a bit of a two-factor problem where you're not just solving the electromagnetics, but you're also trying to work under the constraints of shape, size, thickness, and other environmental parameters. And without doing the details, we developed a solution that basically fit in this little base plate that you can see on the right there, that comprised composite filler materials and a frequency selective surface. And this is kind of where the expertise in the group lies. So I'm just going to give you a few examples of the types of research we're interested in. So for example, here in the microwave domain, I'm demonstrating a two-dimensional Lundberg lens for surface waves. And basically by taking a high impedance surface, you can tailor the mode index. And here it's basically a siphon piper mushroom, which is an electric ground plane with a little capacitor above connected by a wire. And the agreement between experiment and model is very nice here. And this will comprise both analytic and finite element tools to actually validate this design and print it and then get the outcome here. Other examples that are probably really pertinent to the audience we have here are the design and modeling of super directive antennas. So on the top here, you can see there's a pair of helical elements, and if you drive one and you've optimized your design sufficiently, you can actually beam power off this device in one direction with good directivity. And beneath that, another student's been working on the design of artificial magnetic conductors, and that really deals with the problem of placing an antenna close to a metal ground plane, where ordinarily you will get no phase shift, and it becomes problematic when you want to put an antenna next to something that looks like a mirror. You end up with near enough perfect cancellation. But this student's been working on a artificial magnetic conductor comprised of two helices of opposite handedness to give you a degree of control of the phase on reflection, which enables you to basically make this problem a lot more compact. In the acoustics domain, and it's not specific to the acoustics, but we use these models to model the propagation of surface modes on metasurfaces. And again, in the acoustics domain, we've been working on designing absorbers that don't use conventional materials, so you can take some rigid materials that acoustic waves can't penetrate into, but you can enhance the thermoacoustic losses in these small gap regions to create sort of bespoke frequency selective absorbers. So that's kind of the use of the models in the group. We've studied lots of different things at lots of different wavelengths, comprising lots of different pieces of physics. Here we're talking about losses in acoustics, but also you have these kinds of problems in electromagnetics as well. And finally, just before I stop, I wanted to talk about this Max LLG software, which has been generated by a spin out in Exeter. And basically this company, the LLG, stands for Landau, Lifshitz and Gilbert. And it's a special correction that's been built into a finite difference time domain software to solve basically high frequency, high power magnetic problems, where lots of other implementations and conventional codes don't deal with the high frequency dynamics. So if you want to do something high frequency, you really need to build these in to get a proper feel for the local and effective permeability, the dielectric losses, and eddy currents occurring. So I think that's my 10 minutes. I just wanted to flag up this for further information, and please do talk to me or ask questions in the chat. So thank you very much.
Okay, thanks a lot, Tim. Appreciate that. We're going to move on now to Lyudmila Turyanska from Nottingham University, who's going to talk about their additive manufacturing capability. Lyudmila.
Hello. Thank you very much for the introduction and for the opportunity to talk to you today. So I would like to present the activities that we do in the Center for Additive Manufacturing. So the Center for Additive Manufacturing has been established many years ago, and for about 20 years we're working on developing both materials and the processes for additive manufacturing. So we are a research center within the University of Nottingham, and currently we have about 100 members of staff working on development of different aspects of additive manufacturing. We are supported both by industry and by research councils, and our current portfolio is about 20 million. So what is interesting and unique to us is that we are very multidisciplinary research centers. So we work on different aspects of additive manufacturing, from formulation of materials, from establishment of different processes within additive manufacturing technologies, to applications of both materials and processes in different areas, ranging from electronic materials to pharmaceutical industry. So being a research center, we are very much curiosity driven, scientifically driven, but we are industry focused. And in 2015, we had a successful spin-out company, Edit Scientific, established based on our research center. So we are quite well equipped, both in terms of additive manufacturing capability and characterization processes. And the capability ranges from better established, I should say, metal polymer printing to the material deposition on the nanoscale. And today I will show you a few examples of what can be produced using these different manufacturing technologies. So just for those who are probably not familiar with additive manufacturing, it is very much layer by layer deposition, additive, as opposed to subtractive manufacturing technology. So if you look for different ways or different technologies within this area, you will find that there is a range of different approaches used. from laser sintering to in situ polymerization. So what that gives us is that gives us this sort of important, as we say, research triangle. And this is very much where our multidisciplinary research group is. So we are looking across all parts of additive manufacturing, from establishing design as required for application to formulating and developing materials, again, focused for specific application, and selecting the process that can support that. Being a research group, we have ability to tune additive manufacturing process as well as tune materials focused on the design. So this gives us this multifaceted approach to developing specifically the whole process for application. So just as an example of materials that we developed or of applications we develop, here you have an example of what we do on multi-material inkjet. So some of you might know that up-to-date additive manufacturing is used quite a lot by industry, mostly aerospace, automotive industries, etc., where additive manufacturing is used to develop structural parts. We as a group moving more into developing functional materials, additively manufactured functional materials. And this is where multi-material is very important. So what we have established, what we have developed is a few different aspects of that multi-material printing. We can combine additive manufacturing materials or additive manufacturing deposition with conventional silicon-based technologies, with materials or, for example, devices, parts of which are developed using conventional lithography. We can combine within one print different types of materials, and at the bottom left corner you can see an example of how conductive ink, for example, can be combined with polymeric, with dielectric inks. And using those different approaches from, as I said, a mixture of conventional manufacturing and additive manufacturing to those fully additively manufactured approaches, we managed to print structures as they were designed, and you can see an example of that lattice developed on the glass slide, to flexible electronics, to luminescence material within the polymeric matrix. As hopefully you can see a small video with university logo blinking on the bottom corner of this slide. So with this type of inkjet printing, we have resolution of about a couple of tenths of microns. So we are still quite large if we're thinking, for example, about functional devices, but that's the scale that can be suitable for metamaterial applications. Looking at examples of few metamaterial structures that were developed in our labs, and this is just an illustration of what can be done using additive manufacturing technologies. You can see structures developed, for example, using different metal alloys, or structures developed using different dielectric materials. So as I said, we go all the way from designing those lattices, for example, for specific electrical properties or for specific electromagnetic response, as the speaker before me also indicated, and we can develop that lattice, that design, we can deposit it, and we are fairly well equipped to characterize those responses. So one of the beauties of additive manufacturing is a fairly user-friendly ease of upscaling. And in the bottom left corner, you can see an example where a number of different lattices was developed on the same substrate. So we can develop the same type of lattice, or we can upscale the size of that lattice to go across the range of the substrate sizes, approaching that centimeter scale where needed. But as I mentioned before, for some of the metamaterial applications, for some of device applications, we don't want to be on that micron scale, we want to go down on the scale. And as a group, we are very well equipped for additive manufacturing on a nanometer scale, which is quite interesting. It is a fairly new additive manufacturing technologies called either two-photon polymerization. There is also multi-photon polymerization. And what we can achieve using those type of approaches is a variety of different sizes. So these structures are truly 3D, and we can design a range of those structures. So just to illustrate, I've shown a TM image of, an SEM image of different structures printed using the two-photon polymerization. So here we're using polymeric materials, but in our research, we also developed new formulations for two-photon process where we can embed nanomaterials inside those polymers to print functional or multifunctional structures with fantastic geometrical design freedom. So it's an example of that design freedom. You can see here an example of structure that was deposited using different thickness of the line or different width of the line. So you can see those patterns as were designed for specific applications that were developed using our multi-photon additive manufacturing. So what this technology also gives us is an opportunity to combine with other high precision methods. And at the bottom right, you can see an example of how by combining two-photon polymerization with optical trapping, we can embed or immobilize nanoparticles within the 3D polymer matrix, and we can order them for specific applications. So we can control the distance in Z direction, the separation in plane, to achieve the response that's required from those ordered materials. So what we have is we have lots and lots of potential. And this is again just a small video of showing how luminescent materials were embedded in a polymer matrix, and we can control an on-off response by applying external stimuli. So there is still a lot to be done, and as a research center, the opportunities that we offer is to work with industries to address their challenges, as I said, through that triangle where we developed everything together as one problem: the design, the material, and the process. And we can use that triangle to unlock the functionality and to unlock the potential of additive manufacturing. So this is just a quick whiz through of what we do as Center for Additive Manufacturing. I would be very happy to have a chat with you. So again, we work with industries, with larger industries, with smaller industries, both on Research Council funded projects, on Innovate UK funded project, or through supervising joint students. But we are open for conversation with any of you who might be interested. Okay, so I hope I was very fast. Thank you very much.
Thank you, Lyudmila. You have actually caught us up a couple of minutes, I think, so I appreciate that. Okay, the next speaker on the list is Duncan Fitzsimons from 7th Design and Invention, who's going to talk about design and engaging with designers. Okay, over to you, Duncan.
Hello there. So hopefully you guys can see a slideshow come up with 7th logo. So I've been asked to give a very quick introduction into how to engage with designers. So what I'm going to do is give you a brief introduction to what I do and some examples of how my company 7th can help with developing new materials into new products. But also I want to sort of try and give a broader view of exactly how people, companies and people developing new materials and new technologies can engage with designers, and how that can help guide and pull through those technologies into commercial feasibility. So I'm a director of Seventh. We're a small product design and development consultancy. Normally we're based here in this lovely little building squashed between a house and Clerkenwell fire station near Farringdon in London, obviously at the moment working from home. And I started working in design in 2007, I think it is. And one of the first things I designed and developed was this, the world's first foldable wheelchair wheel, which allows a full-size manual wheelchair to be folded up small enough to go in an overhead locker on a plane. You can see that in the Design Museum in London, and it sort of earned me a lifetime of jokes about reinventing the wheel. But it was an interesting sort of kickoff point into what I do now, which is consulting on an enormous range of different projects, working with a really great team to help come up with new intellectual property, help come up with new ideas, new designs, or taking new technologies, new materials, new innovations, and creating feasible, manufacturable, sellable products from those. And that work has taken me into all sorts of different areas. So, medical devices, consumer products like this water bottle for Joseph, which counts how many times you refill it each day, Bluetooth connected blood pressure monitors, and even one of the world's now most common colonoscopy workstations. So there's all sorts of different things that you get involved in as a designer. My area and the area that Seventh really focuses on is creating designs which in particular generate patentable IP. So lots of the work that we work on ends up creating patents and that sort of new innovation. But I want to also make the point that there's lots of different types of design and lots of different types of designer. There's lots of different ways in which design can help. So even with these examples here, for example, with the water bottle, as designers, we were originally approached with the brief of finding a technology and a product that could meet a consumer need only. So the consumer need was people are interested in tracking their daily hydration. How can we create a consumer product that meets that need without over-engineering it? On the other hand, sometimes we may be looking at a product where actually we're looking to take an existing design and reduce cost of manufacturing. And sometimes what's really fascinating is that as designers, you're taking on a multidisciplinary role. So we can look for win-win situations. Can we reduce the cost and increase the usability at the same time? Can we make something more desirable and safer as a product? And it's these areas, this sort of melting pot of different areas, taking into account all the different practical issues that one has to consider in launching a new product, where designers can really help create these win-win situations and develop really exciting new products. So across the broad range of different types of designers, I think it's very useful to look at this model. This is a sort of my own paraphrased version of a fairly well-known model of what design is and where it helps out. And starting off, you have this sort of idea of, from the left here, these little stepping stones and the blue arrows represent incremental technology push development. So it's typically the scientific process. It's coming up with new ideas, establishing them, proving them, standing on the shoulders of giants and making a leap to the next new idea and the next new innovation. And on the far right-hand side, you've got this other thing, which is all the human wants and desires. And by their very nature, there is a gap between the two, because what people want and what people dream of is always a little bit removed from what's currently possible. And so there's constantly ongoing this situation where R&D and development is trying to strive towards achieving these goals over on the right-hand side there. Now, in its simplest possible sort of form, you can look at the stuff on the left as academic research and scientific development and engineering development, and on the right you can see that as people's dreams and wishes and marketing goals, for example, and sales goals. But it's actually a lot broader than that, and takes into account all sorts of other sort of issues, such as the sort of the wants and desires of market-driven economies, but also government-driven safety requirements and the practicalities of making a product work in the current world. Now, what's interesting is that in this gap, this is where designers live. They inhabit this space, and they are obsessed with this space. And that's the really important thing to understand. So designers are working all the time in trying to connect the dots. They're trying to find these latest technologies, these latest scientific advances, these latest materials, and they're trying to join them up with the things that people dream about, the things that people want, the things that people want to buy or want to use or want to have to make their lives better. And so they are obsessed with what's possible in this space, but they also work in helping connect up the dots within that space. So a couple of different ways in which designers can do that, and this is what's really useful for everyone to think about is this is where you can make use of a designer to help bridge a gap or help progress things. Is, for example, designers can help in scoping and creating a design vision. So a very common thing that designers and design engineers do in collaborating with a technology partner are that they will talk to a company that's developing a new material or a new technical innovation, and then they will do an exercise in scoping forward. So they will say, okay, well, let's match that technology to this consumer or this human need or wish. Let's scope it out. Let's actually flesh it out. Let's kind of create a vision of what that product might look like, and create a tangible product vision. And by tangible, that might be a mocked up working prototype. It might be a fake TV advert of what something in 5 years' time of how the world might be different, and people might buy a different type of product or live their lives in a different way. And that's a really valuable thing to be able to look at that and look at different use cases. So let's match this technology to these different types of human wants and desires. And then, because designers are very often involved in product development, taking a product through to actual manufacturing and sale, there's then a case of taking that vision and stepping backwards towards the technology. And this is fantastic, because what you can do is you create this blue sky prototype of some form or other, and then you start to bring it back towards the technology in a way of making it more and more feasible and more achievable. And that is done in parallel with the people developing the technology itself moving towards the design vision. And so you're creating a vision and a goal. You're then working backwards towards the technology to make it more achievable. And at the same time, you're giving those working on the technology a very clear target and a very clear thing to focus and aim for. And an absolutely perfect example of this is the automotive industry. So within a car company, traditionally, the design department is very much just about creating these visions. So, within the design department of a car company, it's all about clay models. It's all about very, very futuristic visions of how one might interact with a car. And those visions serve the purpose of creating a very clear guide for the engineers within the company to develop their technology forwards. And so what you'll have is you'll have a company launch and present a new concept car for a new concept for a vehicle. And then there's typically a 2 to 3 year period whereby that concept is pulled back towards the engineering, and the engineering is driven towards the concept, and that concept pulls the engineering forward until the actual car is then launched. Great example of this is the Tesla Cybertruck recently. Absolutely crazy concept, landed, and then right now you can see that has created a hugely ambitious goal for everything within the company to drive towards and to try and achieve. And the next thing is also within this space, designers, because they're working in this area, they are bringing in a multidisciplinary view. So in working backwards towards the technology, you're then bringing in the very practical issues of marketing, manufacturing, packaging, if that's a factor, human factors, regulations and safety regulations, desirability of the product. Are we going to create something that's incredibly functional but looks horrible and therefore no one will buy it? And so there's so much to sort of mix into this melting pot to get your technology and pull it forward to a successful outcome. And one final thing that can be done is to create entirely new opportunities. So another role that designers often take is to try and discover entirely new opportunities and then sell that, so that people can realize there's something that they didn't even know they wanted until you've painted that vision of it. And so you can pull the wants and desires of your target market and pull the technology towards this new vision. And the sort of superpower that designers have that they use to achieve all this is prototyping with a big capital P. And by prototyping, I don't just mean 3D printing an early version of the product, but mocking things up. Like I said, fake TV advert, looking at ways that storyboarding how people might interact with a new material, a new product, a new way of living. Looking at could just be product visuals of what the product might look like, and this serves the role of creating pull for your R&D focus, but also it helps bring in investors, it helps get future customers on board, it helps generate press and news coverage, and all of these things at the right times can be incredibly useful for developing a product. So a quick example I want to show of some of these things is a startup that I'm involved in. So I'm a director also of this small medical device startup called Solar Surgical. I think it was Medilink MedTech Startup of the Year a few years back. And what we did was it started off with a surgeon who realized that he was the bottleneck in treating wet macular degeneration where he worked. And the wonderful thing with that in that situation is that there is a drug that cures this debilitating illness, which can eventually make you blind. And all you have to do is have a series of injections spaced over a number of months, and it will cure that condition, which is fantastic. The problem is that the injection has to go in a very specific place, a very specific depth, and if you get it wrong, it could damage muscles that control the lens in the eye. Now, what this means is that it is usually just the surgeon who gives these injections. And the surgeon in question, Sam Evans, realized that actually, if more people could give this injection, then he wouldn't have such a waiting list of people and more people could get treated. And he had a fantastic idea of saying, well, if there is a guided needle, a needle that is specifically guided to give this injection, that means that more of his colleagues can help get people through the system. And getting there was all about prototyping. It was also about getting all the right people around the table. So we formed a company that involved 2 surgeons, myself as the technical input, and also experts in marketing and in regulatory affairs. And what we were able to do was say, well, let's design a product so that it is quite easy to CE mark, so that it's quite easy to manufacture, so that it does the job that it's required, and get there very fast. Here showing some of the 3D printed prototypes where we were very quickly on a very practical level able to get from first idea right through to manufactured and manufacturable product. And the outcome here was that within 18 months we were able to take something from first idea through to CE marked product in the market. Sorry, I've just lost control of my slides, so I'm trying to get through to the next one. There we go. So this is not a real eye for those who are squeamish, it's a plastic one. But here you can see with a 3D printed prototype, we're very quickly able to demonstrate repeatability, reliability, function of the product, and also the fact that we can integrate stick safe, needle safe functionality into the product. So it's safer as well as in other respects, as well as being safer to give the injection. And going on about the extra ways of having prototypes, this is also a prototype. This is a computer render of the product before the product was ever made. And with the combination of physical usable prototypes and visions of the product like this, we were able to really pull everything forward and show how the product could work, and able to get it manufactured and sold very, very quickly. One final point I want to make is anyone who's in the situation where you have an amazing cutting edge technology, but you're not yet sure if you've got the killer application for it, absolutely please share your work with design students. places like the Royal College of Art, the Dyson School of Design Engineering, the Architecture Association's Design Research Laboratory. These places are full of people who quite often, if they're postgraduate, they've already worked in architecture, engineering, business. They've gone there and they are ravenously hungry for new ideas that will enable them to change the world in one way or another. And there is an endless list of incredibly successful new businesses and new products that have come out of startups from graduates from places like this, where they've been shown a new material or a new technology or a new physical effect whilst studying and whilst in this mind space of just creating something that's going to change the world. And it's, from my point of view, I think an absolute no-brainer to go and show what you're working on to people in these places, and give it to them as something that they can use, a tool that they can use to create something that you never would have guessed of. So yeah, that's my last point. Thank you very much. Any questions, please pop them on the Q&A or feel free to get in touch. Thank you.
Okay, thank you, Duncan. Thanks for that run through. Very useful, very interesting. The last speaker of the morning, before we try and get a few questions in, is Emma Fadlon from the KTN, who's going to talk about access to finance and specifically, I believe, what investors are looking for. So over to you, Emma.
Hi. Just to say that this session, actually, I was not talking about access to finance. I think that's in a later session. I'm talking about what support KTN can give around grants and funding. So just to introduce myself, I'm from the investment team at the KTN, and I'm just going to give you an overview of what support we can give for innovation within the KTN and within the sort of the technical sector leads, as well as cross-cutting teams such as myself and the team that support around the EU grant funding. We will be covering investment at a later presentation. So I think the first thing that I wanted to talk about is, how do you fund your innovation? And actually, for most of you, you'll be looking at grants, you may be looking at debt finance, you may be looking at crowdfunding, or you may be going out there and trying to raise investment, equity investment. They're all valid approaches to getting your funding and financing your research and your development and your company growth. However, quite often people come to us and what they're looking for may not be just funding, and there's a wider ask. So I want you to think widely about what is it that you really need as you going through your innovation development. And is it collaborations, such as the previous talk, we're talking about, how do you engage with designers and to support your innovation? Or is it really that you need money to execute, or you need to have a wider collaboration network because you need to build your supply chain? So the first area I'm going to talk about is around grants and the different sources of grants. So I think the first thing we need to think about is, where are you based regionally? We have very different approaches to funding based on your local enterprise partnerships. They may have strategies around certain areas or sectors. They may still have access to the ERDF funding. They may have innovation vouchers. And the devolved governments as well have different funding and finance programs to sort of England alone. So be aware of what's happening regionally. Now, I know you had an introduction from Innovate UK around Innovate UK Edge and also the catapults. And those are really useful organizations and networks who can tell you around what's available for you based on your geography, as well as engaging with your local enterprise partnership. Wherever possible, KTN will be promoting what's happening regionally through our newsletters, and we'll talk about that later. Nationally, there's a range of funding available, whether it's for SMEs, typically it's driven through government departments. And it could be delivered through Innovate UK funding mechanisms, or it could be delivered through other government departments. So you need to have a look what's going on, look at the website, understand what trade associations or organizations will be promoting these different grants. A lot of the local enterprise partnerships will have access to grant searching tools like Grant Finder, which can also help you find what's happening regionally and nationally. They're quite blunt tools. They tend to work on the SIC codes, so you do have to spend a little bit of time sort of working through and identifying what's best. The other area to look at is European funding. Now, currently, the UK and EU is confident that we'll be participating in the first set of funding calls, and we'll have equivalent rights to those entities from member states. The UK organisations will still be able to apply to the grant element of the SME accelerator, but not the equity, so that's the investment side of that fund. And we will be able to participate in the Horizon Europe partnership. So up until the end of this financial year, we've still got Horizon 2020, I think. So we've got those new calls coming up, but it's a changing landscape. There's new stuff being published all the time on the website. We have a team within the KTN who is observing this. And you also have your Innovate UK Edge, your regional support, who will be able to help you with those applications and know what's happening. So do not discount European funding. I'd also say that depending on the sector you're in, there can be funding from other territories, from the US government, etc. If you've got something that's unique and special that they don't have, which is going to sort of unlock a technology or capability, you may be eligible for that funding. So don't discount looking at what other funding opportunities there are. You'll know if what you're doing is sort of unique and special and sort of fits in. There will be some strange terms and conditions possibly around that. There's certainly quite often a requirement to manufacture within that territory. So do look out for those other opportunities. And the fourth source of grants that we really encourage you to think about is what's happening in the third sector. So that's the charity sector. As we've said, sort of the international grants, corporate venture R&D, and also non-governmental levy boards, and they could be both national and international. Levy boards, typically, their particular organisation will act as top slice a certain amount of the profits or the income that organizations in the sector make, or there'll be a subscription fee, and then that goes into addressing R&D challenges. So typically we see that in the energy, utilities, nuclear industry, but you also have it in areas such as agri-tech as well. So there are certain countries where you have levy boards are very, very strong in supporting innovation. So you could actually get into a grant in a collaborative process. So how can the KTN help with securing grant funding? Well, we've heard about the challenge-led responsive applications in Innovate UK. There's investor partnerships. There are managed programs which are delivered through partners such as the catapults and other centres of excellence. There's the commissioned research grants and their knowledge transfer partnerships. So the KTN promotes these. We'll run briefing events. We can support people in identifying who they would want to work with, where to find match funding, so support you in thinking about what duration or amount you should be going for based on the stage of your innovation, and give you some guidance around what capabilities and where the gaps are in your application. But remember, these are thematic, particularly the challenge-led, and so you might want to think about which part of your innovation matches that grant funding. And again, this is where the KTN can help you. You don't always have to be the lead. You could be a partner or a collaborator, and we could introduce you into those applications opportunities. Small print is another area where both Innovate UK competitions team and the KTN can help, particularly around what's in and out of scope with a particular call or funding program and what maybe the aims and the objectives are. This is particularly useful if you're new to raising grant funding from sort of government bodies. But don't discount other government departments. You may find the Department for Transport chooses to promote its programs through its own competitions process rather than through Innovate UK. BASE has a number of programs where it actually funds directly and actually is partnered up with incubators and accelerators, for example, with the Clean Tech Agenda. There are obviously the EU programs where you might want to collaborate in. And the KTN also runs Innovation Exchange, which is where large corporates put out a call of, we are looking for a solution to this particular problem. And then you put in your application. It's a fairly straightforward approach. And then you're matched to that innovation need. And then the company will decide who they want to work with and collaborate with. I've put in a link on that. But grants, there's pros and cons. They're great, there's high risk, they're seen as zero cost to the organisation. It adds credibility, 5 assessors saying this is good and needs to be funded. And it can leverage you additional funding from investors or from other organisations. But they are difficult to locate. They're rarely 100%. So you need to find that match funding, and they can be distracting and they can be paperwork heavy. You know, you need to be able to manage that. So again, if you engage with your KTN sector lead, they can certainly guide you through that decision-making process, help you sort of think about which is the best way to approach in funding your innovation, whether to go for a grant, or to try and partner up with somebody. The other thing that I'd say, I know that in this sector we have a lot of early stage companies, is there's some issues around grant funding. Quite often it's about getting your match funding, sorting out your background and foreground IP, having the right agreements in place. If you've got corporate grant funding, what terms and conditions? What do you do if you meet commercial milestones early? And we do recommend, if you've got anybody else, negotiate heads of terms. So they all look very nice, the top of the iceberg, but actually there's a lot more going on underneath. So do think carefully about how you approach if you're new to that. We have a good application guide to help you with your grant applications. And as I said, if you're new to applications, then we can help you with writing those. The other area we can help in is in collaborations. So how do you find your partners for grant applications? Do you need to access technology and new innovations? What collaborators do you want to work with? Do you have value chain partners that you need to work with? Who are they? Do you know who they are? We can make introductions. If you need to secure your supply chain, if there's a need for knowledge exchange, and also we can help you engage with your stakeholders. So think wider about the KTN offer and what you actually need. Is it just funding, or which is how most people come to us, or is it more around the collaborations and there's added value? There's also the element of insights. When you're developing your value proposition, which we talked about in the first workshop, you really need to know what's happening in the sector. What are the trends? What are the emerging technologies? What are the needs? What are the issues? And this is where working with the KTN, either through innovation networks, such as this one, engaging with our stakeholder networks, working with trade associations that we can introduce you to, the events and the conferences that we hold. There's a really great way of getting a lot of information very, very quickly and very efficiently. We have I3EP network, for example, which we are supporting, which is started off from this large infrastructure and the needs of the large infrastructure providers of engaging with innovations and SMEs. So do talk to us if you need to understand what's going on in the trends in the sectors to validate your application and understand what are we really doing? Is it really aligned to what the industry needs? So it's a wide community. Investment. So this is the introduction to investment and the sources of funding and finance. So one of the other areas that organizations come to us is because they're looking for equity investment, and they're looking to get that match funding to the grant application, or they need that investment in order to start delivering on their business development and growth plans. There are a number of sources of equity investment, and the first thing I want to highlight is the importance of the Economic Development Bank. Now, British Business Bank works through funding partners, but it has a number of delivery partners, which are regional funds, as well as specific funds, and it's always creating new products and services. You can also look at the British Patient Capital, British Business Investments. There is the Angel Co-Fund that's available. There is the Director's Loans, which is up to 25k and 12 months of mentoring per director. They're all delivered by different partners in the region, so you need to go onto the website, and I would really recommend you go to the Finance Hub. If you're in Scotland, Northern Ireland or Wales, you will also have your regional development funding, finance and support. So do have a chat with whoever is the lead of that. Go onto the website and see what's available for you. Or it could be that one of your partners or collaborators is based in one of those regions, devolved governments, and is eligible for funding, which can support your innovation development. So how do we help with investment? I think there's some key areas to look at. There are investor partnerships, which are funded by Innovate UK, where they put grant funding and investors who are committed to supporting projects in certain themes. They're selected investors, so we can help with your applications and sort of promote those investment partnerships. We run investment showcases. They're thematic and they're in various, cover various approaches. I'm running a net zero chemistry industrial biotechnology with a partnership over 6 months, or we can have just investment showcases linked to particular events and activities, or four-day programs. There's quite a broad range of them. Again, look at our newsletter, see which ones are relevant for you, and apply. We can make introductions to investors. That's usually when we've qualified what it is you're looking for, and that we've really made sure that we've addressed any gaps in your investment plans. And we have a range of regional angel investors, as well as sort of early stage VC networks that we work with quite closely. We run showcase events where we'll get you to pitch and showcase your innovation in front of stakeholders, and they could be investors or industrialists and people with sort of funding finance routes. We run pitching events. So again, there'll be sort of showcases where we've actually got investors we know are actively looking for companies and deal flow in that area. And those are done through usually delivery partners, other government departments. We run investment readiness programs. We provide investment readiness support. We have some guidelines online on what you need to be to investment ready. And we also can do some signposting to incubators and accelerators, as well as other support organizations, in order to help you kind of leverage that support that you need. I'll go into more detail in my next workshop with you around what investors are looking for, particularly in early stage innovations. But I think the most important thing is what we're here for is to really help you stand out from the crowd. We really want you to be able to showcase what's unique and special about you, about your innovation, where you sit in that marketplace. And a lot of what we can do in helping you at the KTN is to really define and also refine your proposition to give you a much better opportunity to raise that grant funding, leverage that grant funding to raise investment, or to raise investment in really a very competitive ecosystem. So where do you find out everything? Do sign up to our monthly newsletters, select which sectors are relevant to you. You may sit across several of them, and we push through those newsletters all the information we have about upcoming grants and funding applications. So on that note, I think I've had a bit more than my 15 minutes, so thank you very much for your patience, and I'm very happy to take any questions.
Okay, thanks a lot, Emma. And you're not the only one that's had a little bit more than their time, so don't worry about it. We have kind of eroded pretty much the entirety of our Q&A session. So we were due to finish at 12, and by my clock, we're about 10 seconds away from that. So I don't know if I dare squeeze a quick question in, or we just carry on. What do you think, Steve?
I would guess we can squeeze a couple in, unless
let's go for a couple. I think there's been some really good Q&A on the Q&A box, and I noticed the speakers have been answering them pretty clearly. So thank you for that. One of the questions, this is really for John and Steve, Steve O'Leary. Will the KT, Steve Morris, I guess. Would the KTM be open to running or facilitating a workshop in a single company using the Innovation Canvas to help commercialize metamaterials?
Shall I come in on that one?
Yeah, go on, John.
Yeah, I think we could definitely look at doing an introduction workshop, for probably best for several companies to get most value, and then I think we'd have to have an individual discussion about working with an individual company, depending on whether it was a short intervention or something that needed a bit more time. But I would suggest starting with a broader. I mean, I could do an expanded version of the 10 or 15 minutes that we had earlier. But the people can always make a start with the digital tool, which is free to use and is a self-help tool.
Okay.
Thanks, John.
All right, thanks. The second question, this is, I guess, for Stephen O'Leary and John jointly, and I don't really want to start a fight here, but which if I was an SME or a startup, who should I be going to? Should I be going to KTA for support, or should I be going to Innovate UK Edge?
Well, of course. Stephen, what are you going to say?
My view would be approach both. And I think the more information you've got out there, the better prepared you are. And I think as an advisor, I think we'd be a very good point of call for your first point of call. And we are there to advise and direct. So not to sound vague, but I would reach out as many points of contact as you possibly could.
Yeah, I completely agree with that. And other resources are available, such as EEN for startups and so forth.
Or Innovate UK Edge, as they are now, which are going to be, and they are going to be providing a lot more regional support. Your local enterprise partnerships are really, really great. Your growth hub partners as well, particularly if your sector matches onto the regional strategy. So I would say you can never have enough friends. So you should work all this content. Also, you never know when you're going to need that particular knowledge or information. So get engaged with your local science parks. Your university base is a really fantastic source of knowledge. Universities get funding to support companies and SMEs. It allows you access into those capabilities and resources with the IP sorted out, the catapult networks, etc. You might sit across more than one technology interface. So when you're building your value proposition, you're really understanding what the needs are in your community, what problems it is you're solving, understanding who you need to engage with. Start building a stakeholder map. So one of the things I do as part of a carry on from when I've done the innovation canvas is started working under each of those headings to build what is your stakeholder map, what are your channels, what do your value chain partners look like, and then start making a list of what and who should you be engaging with in order to execute on your commercialization plan. Okay. The more you do up front, the better.
I think I would just add that whichever one you go to, whichever one of you of us you go to, you will get access to the others because we all work together. I mean, it's not we're not working as single entities here. Sorry, now.
Okay, great. No, I think we're just about out of time, and I don't want to avoid too many people's lunches either. So, I mean, just for me, just to say thank you to all of the speakers. You covered, I think, a lot of topics this morning. I think very useful. I think also, I hope it's been useful to all of the attendees. I hope you've got something out of it. And we're all available on the Meeting Mojo platform from I think 12:30 through till 2 p.m. So if you need to make contact, I think in your registration details there was ways of making contact with us all and booking a slot for a one-to-one meeting. So I'd advise you to take that opportunity. But other than that, I'd just like to thank everybody and have a good rest of the day. Thank you very much.